In the previous lab, when we talked about subnetting, the subnet requirements were given to you. You were told how to divide them, not really told how many computers each subnet had to support, anything like that. So in this lab, we're going to go a little bit further. We're going to start off by talking about determining what subnet mask we actually need. So given a specific number of hosts, what subnet mask do we need to put that many computers on a subnetwork? For example, let's look at the table. We've got the first example, 225 hosts. So hosts again here refers to laptops, printers, desktop, smartphones, anything that might connect to our network. To support that, we need a subnet mask of at least /24. /24 would work without wasting IP addresses and without having too few IP addresses. But why? Let's talk about how we come up with this information. So thinking back to our formula for the number of usable hosts on a subnet, 2 to the n minus 2, right? So what is the n? You can think of it in a couple of ways. It's the number of zeros in a subnet mask, 32 minus CIDR. Those two ways. So number of zeros or 32 minus the number of ones. It's the same thing. You can just think of it backwards and forwards. So we can create a little table here essentially to look up what that would be. So our subnet masks, you can't have really have a subnet mask that is I'm not going to put the slash here, so we can do some math on it. 32, a subnet mask of 32 is all ones, all 4 octets, right? It's really not usable for subnetting because that is essentially a shortcut for a specific computer. 31, again, is not really that usable either. 30 is the biggest subnet mask that we can realistically deal with. So let's use our formula. It's 2 to the, so n. What's n going to be? Well, the CIDR is the number of ones, and we know there's 32 bits in there. So 32 minus, we'll just refer to that cell, minus 2. Okay, so we know a CIDR notation of 30 can support 2 users. Now our subnet mask can get smaller. As our subnet mask gets smaller, the number of hosts, let's copy this formula down the line, we'll see what happens. The number of hosts, or the number of computers that we can put on that network, starts to get bigger. So with a /30 network, we can only put 2 computers on that network. So you might think, well, why would we ever want to do that? Well, when we start configuring routers and we have to put an interface on one router and connect it to another interface on a different router, each one of those interfaces needs to be on the same subnet, but we don't need more than 2. So we will use this /30. With a /29 network, we can put 6 computers on there. You can see it gets bigger. It basically doubles +2 every time. Again, just as a general design principle, you typically don't want to go over 1,000 computers. Performance starts to degrade. Things just don't work properly. There's exceptions to every rule, but for our purposes, just 1,000 is basically your upper limit. You would have to have a good reason to go above that 1,000. But they can get bigger and bigger. Theoretically, let's say if we had a /8 network, again, we could put millions of computers on there. everything would break, everything would be slow and terrible, but in theory, at least we could do it. So using this table that we've constructed, let's look in our packet, ask for the number of hosts and the subnet mask we need. So with 225 hosts, we know that 225 hosts, it's between, essentially, a /25 could only support 126. A /24 supports 254. So we are, in a way, wasting 19 IP addresses, but trust me, we don't worry about wasting 19 IP addresses. That's fine. So that's why this subnet mask is going to be 24. Just know there's an implicit slash there. It's a /24. Okay, so let's look. We need 10. I'm just going to copy from the PDF 938, 2, 12, 490, and 56. Okay, so if I want 10 computers on a network, what's the lowest subnet mask I could use? So we're going to look it up here. We know /30 can't fit it. /29 can't fit it. /28, yeah, that works. I'll type it in there. /28. I'll put that slash there. Now how about 938? We know none of these are big enough until we get to /22. How about 2 computers? Well, that's how we start off. And we can do it with /30. 12 wouldn't fit in /29, but it can fit in /28. 490. Nope, 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 nope. There it is. 490 can fit there in /23. /23. Good. 56 fits right there in /26. Okay, so this table is going to be very useful. So know how to make this table. You can make it in Excel, but also don't just memorize the formula or copy the formula I used here. Just kind of know the relationship. As the subnet masks increase, the number of usable hosts decreases. So in this next section, we're going to use this when we do variable length subnetting. So before, we took one subnet, right? And we just started dividing it into half and half again by just increasing the subnet mask. However, you could have one subnet that you divide the first half into 2 equal parts, and then you have a bigger section with more IP addresses. They don't all have to be the same size. So that's what we're going to do here. So for the first example, we're taking the address 192.168.1.0/24. Usable IPs. We want one with 20, one with 6, and 2 with 2 usable IP addresses. So that's how we're going to start off. We want to waste as little space as possible, but making sure that we put all those computers on the same subnet. Subnet, oops, I can't type. Subnet address, subnet mask, first usable IP, last usable IP, broadcast address. So how many usable hosts do I have in this subnet to begin with? The only thing I need to look at is the subnet mask. So it's /24. I'm going to go back to my first sheet. If we look up /24, I have 254 usable hosts. Well, I only need a handful of computers, 30, so there's going to be plenty of extra IP addresses. But we are going to create the network to support these. We're going to essentially take this chunk of 254 and carve out just enough for these IP addresses, and then we'll let the next person do with those IP addresses what they will. So to do this, we'll start with the subnet address, 192.168.1.0. We're going to start at the same place as the given subnet address for us. Okay, now we need 20 usable IP addresses. So think, before I switch back to the table, can you think what subnet mask would support that? It's kind of an unusual number for a subnet. If you said /27, you were correct. That's a 1. If you've got that memorized already, congratulations. You're doing fantastic. So we know to support that many people, we need to use /27. So what's our first usable IP address going to be? 192.168.1. Remember, all we do is add 1 to the subnet address, 1.1. Our last usable IP address. So that is going to be the number of hosts plus the subnet address. So the number of usable hosts here is 30. We're going to add 30 to our subnet address, 192.168.1.30. And the broadcast address is just the last usable IP plus 1, 192.168.1.31. 31. Okay. So really, figuring out the last usable IP is probably the trickiest part, like always. But if we see /27, we use our formula 2 to the n minus 2. So 2 to the 5th is 32. Minus 2 gives us 30. We add that 30 to our subnet address to get our last usable IP. So that one's good. So let's come to our next subnet. The requirement is for 6 hosts on that network. So our network address is just going to be the last broadcast address plus 1. 192.168.1.32. But we're not going to use the same subnet mask this time. We're going to change it for this subnet. So we need 6 computers now. So let's look at our table. Let's figure out what would support 6. Well, it just so happens that the /29 will support exactly 6. So that's good. /29. First usable IP is going to be 192.168.1. We add 1 to 32 to give us 33. Our last usable IP is going to be the subnet address plus the number of usable hosts, which happens to be 6, which is our given requirement. So we had 6 to 32. I'll give us 192.168.1.38. The broadcast address, as always, is just going to be the last usable IP address plus 1. 192.168.1.39. Just add 1 to start the next network address, 192.168.1.40. So how many computers? What's our subnet mask to support 2 computers? Well, we can look it up here if we don't remember it. It's going to be /30. Okay. /30. First usable IP address, subnet address plus 1. 192.168.1.41. Last usable IP, 192.168.1. We take this .40 and add the number of usable hosts to get that last usable IP. So it would be .40 plus 2, which would give us 42. Add another one to get the broadcast, 192.168.1.43. And again, you can see that these are contiguous now. 40, 41, 42, 43. So this will be 44. 192.168.1.44. Same requirement, 2 usable hosts, so this is still going to be /30. 192.168.1.45, because we're just adding 1. We'll add 1 again. 192.168.1.46. 192.168.1.47. Okay, so let's check this. I'm going to pause the video real quick. Okay, I brought up the Tunnels UP subnet calculator. We used this previously to check our work. We can check our work again. Here's a really cool feature. Let's say I'm given the IP address, the network address 192.168.1.0. And we want 20 usable hosts. I can put #20 there. That's just the syntax that the website designers came up with. I click calculate and scroll down, and it tells me that to support that, I need a /27 mask. It also gives me the usable host range. So did we do it correctly? 1.1 through 1.30, broadcast address. Looks good. Gives you the CIDR notation, gives you the dotted decimal notation, gives you the binary representation. It should all be consistent. It tells us the number of usable hosts on there and how many we requested. So that's excellent. We also said that, what was our next one? 1.32, and we needed 6. So let's calculate that just to check our work. Tells us we need a /29 subnet mask. Starts at 33. Last usable IP is 38. That checks out. Broadcast is 39. All that checks out. So again, number of usable hosts is 6, and we requested 6. So this is good. This is a good way to kind of check your work as you're going through this. You should understand how to do it by hand, but to check your work, if you're an actual networking professional doing this, you want to check your work. Use, you don't want one little typo in your Excel spreadsheet to mess you up. Use the calculators. They're your friend. All right, so let's do this again. I'm going to just delete all this. We've got 192.168.32.0/24. So again, we want 4 equal subnets. One with 100 usable IPs, 2 with 30, and 1 with 6. Okay, so our first subnet address is just going to start at the same spot, 192.168.32.0. Okay, our subnet mask. What do we need for 100? So I'm going to guess 128. It's going to be /26. 26, is that right? Whoops. No, /25. Did the math wrong in my head. I guessed wrong. Okay, so 100 will fit in this subnet well. There'll be a couple of extra. That's okay. So we need a /25. First usable IP, 192.168.32.1. The last usable, let's do this one by hand before we start using the calculator. What would the last usable IP be? So pause the video if you want to calculate it. So it equals 2 to the n. What's the n going to be? 7 minus 2, 126. 192.168.32.126 broadcast address is just going to be that plus 1. 192.168.32.127. So let's see, should we check our work? 192.168.32.0 pound 100. What does it tell us that we need? It tells us we need /25, so we're right there. Network address, usable host range, first and end, that's right. Broadcast address, everything is working out just fine. We've got 26 unused IP addresses in this range. That's fine. That's nothing to worry about. We don't have to divide this into smaller chunks to make it perfectly allocated with no wasted space. That's not a concern. Let's just use a calculator for the next one, just for giggles. So the only thing we have to know for this next one is what's our subnet address. It's just the last broadcast address plus 1. So 192.168.32.128, and we need 30. So we calculate that. And we're good to go. So we've got our information here. Pull this down just a bit, or maybe move Excel up a little bit so we can see more information. Our network address. Sure, let's copy and paste. Text only. /27. Usable host range. We could type it out, but why not be lazy, right? Last usable IP address. Keep it as text if you just copy it. Without changing the formatting, I know you copied it. It's not bad, I'm just saying. It's sometimes easy to tell when people copy work from the internet. Okay, let's do the next one by hand. 192.168.32. What's our address going to be? 159 plus 1 would be 160. Same requirement for the number of usable hosts, so we'll just copy that /27. 168.32.1 plus our subnet address, 161. Last usable, that'll be 192.168.32.190. So how to get 190? My number of usable hosts is 30 on this subnet. So I take 160 plus 30 gives me 190. Broadcast address is just that, plus 1. So my next subnet address is going to be 192.168.32.192. So for 6 hosts, I need a /29. /29. First usable IP address, 192.168.32.193. So 2 cubed is 8, minus 2 is 6. So 198. 192.168.32.198. Looks about right. 192.168.32.199. That's an interesting one. Let's just double check that. 192.168.32.192. And we want 6. So pound 6. Yep. Everything looks like everything checks out. So know how to do that. Know how to fill this out by hand, but yeah, use the calculator. The calculator is your friend. It's not cheating to use the calculator. But if you just always use the calculator and you never actually sit down and try to do it, well, that's when people start to run into trouble. So again, this is just kind of practice, but if we had 192.168.0.0/23, starting with the 23, so we want 4 subnets, one with 200, one with 62, one with 30, and one with 14. All right, let's just figure out the subnet masks we need. So for 200, we come down here, /24, that's what we need. Figure out the other ones. I'll just, pause the video, go ahead and try to figure that out. /62, so that'd be /26, /26. 30 would be /27, and 14 would be /28. Should we use the calculator? 192.168.0.0, and we want 200. So yeah, subnet mask matches what we expected. Our first subnet address is just going to be the one we were given. So 254 usable hosts, so add 254 to the subnet address to get the last usable IP, add 1 to that to get the broadcast address. I add 1 to that broadcast address to get the subnet address of my next network. So 192.168. So 255 is full, so I have to carry the 1, it'll be 1.0. Alright, once we have that network address, 1.0, then we can feed it, we could say /26. We could say /26 because we already figured that out. Or we could just double check our work and say #62. Calculate that. So yeah, it gives us the /26, which we already figured out. Gives us the start and end, 192.168.1.1, 192.168.1.62, subnet address, plus the number of usable hosts. So the broadcast will be 1 after that, 192.168.1.63. Add 1 to that to get our next network start, 192.168.1.64. right? And we want 30. So this will be a way to check our work again. So /27, that's just what we figured out. 192.168.1.65, 192.168.1.94, 192.168.1.95. Add 1 to that to get our next start, 192.168.1.96. Sure, let's calculate it again. 1.96 pound 14. Calculate it. So /28, just like we said. 192.168.1.97. Whoops, 97. 192.168.1.110. 192.168.1.111. So one thing to notice here, as we're using variable length subnet masks, we can't follow the pattern because these subnet masks are not equal. You will see some patterns start to emerge. Your subnet address will always be an even number. I'm trying to think if there's any exception to that. I don't think that there is. So it's going to end with something like 0, 32, 16, 64, something divisible by 2. The broadcast address is always going to be an odd number. 255 is very common. Just the way it goes. Okay, So that's good. Now, there's a couple things we should... That information is given to you. So somebody took some sort of business requirements and said, okay, you as the network designer, here is what we need you to implement. We have 200 students who need access to the network, 62 instructors, 30 administrators, and 14 coaches, whatever it is. They've given that to you. Now, you're going to be starting with a blank slate to design subnets. And now you should know that there are 3 different network private addresses. So private means that you have control over these IP addresses. Businesses and organizations are free to use these IP address ranges and do whatever they want with them. They're not essentially part of the public internet. They're reserved specifically for businesses and organizations to do networking. So 10.0.0.0/8, that's in the private space. 172.16.0.0/12 and 192.168.0.0/16. So I would be willing to bet 95% of you, maybe close to 100%, if when you set up your wireless router at home, when you check your IP address, your wireless router probably gave you an IP address in this 192.168.something.something range. It's just very common. If you need more IP addresses, the 10.0.0/8, you can subdivide that network into thousands of subnets. So if you're a big corporation and you're designing, for Acme Corporation with 500,000 employees, you would want to use this 10.0.0.0/8 IP address range. It doesn't really matter, just if you're going for a super huge network, use the 10. If it's something small, 192.168 works just fine. You could use the 10.0.0.0/8 network in your home. There's nothing wrong with that technically. It's just less common. So here, in this blank slate design, we should use these private IP address spaces to come up with a solution. So scenario number 1, you have a small business with 10 computers. Okay. So we need to balance this with wasting IP address space versus making our job as administrators easier. If this is me, if I've got a small business just in a single location and they just have to connect to the internet, I'm going to put them just on a 192.168.1.0/24. /24 is just very easy to work with. So technically, I'm wasting how many IP addresses? There's 254 usable hosts in that subnet. I'm using 10, so you can't see my air quotes, but imagine I have air quotes. I am, air quotes, wasting, end of air quote, 244 IP addresses. But you know what? That doesn't matter. It's a small business. They're never going to run out of space. That's perfectly fine. If they somehow grow and they need to hire hundreds of more employees, they can afford to have the network administrator go back and change their IP address scheme. So I'd consider that done. Now there are hundreds of correct answers. Other correct answers for number 1, you could have said 10.0.0.0/24. You could have said, well, we only need 10 computers. I'm going to use 192.168.50.0/28. /28, that would have been fine too. For me, I would go with something like 192.168, which kind of implies that it's a smaller network. It's easy to work with. There's plenty of room to grow. But just know there are lots of correct answers. We could have done something like 10.0.0.0/8, just stuck them all on that network. We would have the potential for 16 million devices, at least as far as subnetting goes. There's no way our network hardware could support that many devices, but there's also technically a correct solution. However, I would lean towards the top one as more of a best practice. So let's see number 2. 175 computers in 2 different buildings. So this is a bit ambiguous. It doesn't tell you if there's 80 in one and 95 in the other. Let's just assume that there are a total of 350 computers. So each building, so we'd have building 1, 175 computers. Building, I spelled building wrong. 175 computers. Building. Okay, so what IP address scheme could I come up with here? So again, there is no one-size-fits-all solution. There are lots of different correct solutions. Here is what I would do. So in building 1, I would give it the subnet mask range 192.168.1.0/24. So that's plenty of IP addresses. And for building 2, I would give it 192.168.2.0/24. We would need some sort of router, so they're on separate subnetworks. So everybody on building 1 is on the same subnetwork, and we know that we can fit up to 1,000, so that's okay. 175, we're definitely under that limit. And in building 2, we have the same requirements. And now if these buildings were close enough together, maybe you could have put them all in the same subnet. By breaking them out, you can see here in my IP address, I've included the building number in my IP address scheme. So building 1 has a 1 in the 3rd octet. Building 2 has a 2 in the 3rd octet. So if I were troubleshooting something, if I saw an IP address error and I saw the IP address had a 2 in that 3rd octet, I could say, okay, I can pinpoint that problem, it's in building 2. Other correct solutions, you could have done 10.0.1.0/24, 10.0.2.0/24. That would have been just fine. Lots of correct solutions. What about number 3? Large business, 3 locations, each with 3 departments of 200 computers each. 3 locations, 3 departments, 200 computers each. So here I might make a table. So I might have location 1, department 1, location 1, department 2, location 1, department 3. So we've got 3 locations though. Let's use our friend, Mr. Copy and Paste. Whoops. So we've got all our combinations. So we've got 3 locations, each with 3 departments. They all have 200 computers. So here's what I'm going to do. Let's assume this is a big, and this business is going to grow. They're already big. I know /24 is going to fit all 200 computers for each department, I'm going to use 10.1 for the location, 1 for the department, and 0/24. This one will be 10.1.2.0/24. So the 10.1, that 1 is for the location, and the 2 is for the department. Here I'll use 10.1.3.0/24. So I'm going to use as an IP address scheme that makes sense, that kind of matches my business requirements. So here I'm going to do, can you figure out my scheme now? If you can figure out my scheme, that means it's going to be easy for the next network administrator to understand how to support this network. So this will be 10.2.1.0/24. So the 2 is for location 2, the 1 is for department 1. 10.2.2.0/24, 10.2.3.0/24. And the last 3 should follow the same pattern, right? 10.3.1.0/24, 10.3.2.0/24. So none of them are overlapping. I've got plenty of extra space. In each location, I could add a lot more departments. So when would this potentially fall apart? This scheme that I've come up with here for number 3. Well, if I had more than 255 locations, this scheme would run out of steam, right? I'm told I only have 3 now, so I have built-in room for growth. I can add another 252 new locations without running out of space. I also have a limit of 255 different departments. So I have lots of room for growth, but it is just something that I am aware of. If for some reason I had more than 252 departments, I would have to come up with a different scheme. But for now, I think this would work out okay. And let's look at number 4. So I have a global business with 1 large location that has a data center with 800 servers, 12 floors with 180 computers each, and 100 remote locations that connect via a VPN, which is a virtual private network. But I don't know how many employees at each of those locations. I'm going to assume that it's small, like those are satellite branches. Okay. So I'm not going to type out that whole thing. That's text. 4. Okay. So let's see. So we've got 12 floors, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I've got my big data center here. I'll make this bigger. Oh, let's highlight it. So that's a rough floor. 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Floor 1. Data center. And then we've got 100 of these. So I've got like remote 1, remote 2, these remote locations. We've got 100 of them. Okay, so I'll call this remote 100 and remote 99. So I'm creating a pattern here. I'm not going to actually list out all 100 locations. Hopefully, I'm going to be able to come up with an IP addressing scheme that just makes sense, so I don't have to fill in every single thing. Here's what I'm going to do. I'm going to use the 10 dot scheme here, 10.0.1 for the first floor, .0/24. 10.0.2.0 for the second floor, essentially 10.0.12.0/24, 10.0.11.0/24. So essentially, we can use ellipses to fill these in. That pattern just repeats, right? I don't have to be super explicit about that. Just like here, this pattern should repeat. For my data center, I'm going to use the 10.0.0.0, whole bunch of zeros, slash. Actually, if I did that, I would overlap. Let's do this. 10.1.0.0 slash. I need 800. If I use /22, I can put 1,000 computers in my data center. That's what I'll do. I don't have any written requirements telling me I need to separate the data center traffic, different parts. You may need to based on security if you're given extra requirements, but if you don't have the requirements, then forget it. Now over here, I'm going to use a different IP address scheme. So 192.168.1.0/24. So I'm mixing different kinds of private address space. I'm mixing the 10.network with the 192.168 network. That's perfectly fine. 192.168.2.0/24. I don't have to do it this way, but I'm choosing to. This way, if I'm troubleshooting my network, I know if someone's got the address 192.168.99.0/24, let's say this is our Chicago office. I can say, oh, we got a problem with Chicago. Let's talk to the internet service provider out there and make sure everything's working properly. Maybe there's an outage. 192.168.100.0/24. Now, this is just one of many correct solutions. I'm not saying this is maybe necessarily better than others. Some people might come up with different solutions that work fantastically well. This is one that makes sense to me. It follows a pattern. Looking at the requirements, it seems to fit the requirements. This would be fairly, easy to administer. The network would scale well. I've met all of my requirements. So this is what I might go with. So each of these remote branches, I'm assuming there's maybe 10, 15 employees. I've given them plenty of extra space. Again, if I really like this /24 subnet mask, it's fairly easy to work with, fairly standard. I'm not worried about wasting IP address space. We have literally millions of IP addresses to work with, and I have much less than millions of users that I have to support. So don't be stingy with your IP addresses. Okay, there's subnetting. Hopefully you feel more comfortable with it as you work through the enumeration and you work through thinking through the business requirements. Hopefully it all starts to sink in pretty well. So you should know what the private IP addresses are. Know these three ranges. Know how to determine the subnet mask to support a specific number of hosts. So like this table right here. Given, if I say I want 50 computers on a network, do you know what that subnet mask needs to be? Should be able to divide a network to support variable numbers of hosts, and be able to design a subnetting scheme given a set of business requirements. So go ahead and practice. Go through the video, follow along with me while going through these labs. The best way to get better is just to keep practicing this stuff. Thanks.